I'm going to do section 6.2, so I actually have this typed wrong. I corrected it, but I already had made the copies. So we'll make sure we cross this out and make it 6.2. So 6.1 is an optional section, and this one's supposed to be like briefly covered, but I'm going to cover it more in depth. The only difference between 6.1 and 6.2 is in 6.1 you're doing equations with just two variables, x and y. So I said let's ignore that, and then we'll do 3, and what we're doing in 3 is just what you would do with two variables, okay? We're just doing the more complicated route. So today, bear with me, because it will be a little tedious, but guess what we'll learn tomorrow? A really quick, short way that we can just do it with our calculator, okay? So first thing is to realize is that when we solve a system of equations, that means we're trying to find one point, x, y, and z, that satisfies all equations. So it's kind of interesting. So these are the things that we're allowed to do, okay? And at first, they're not going to make sense to you, but when we actually jump in, they'll make sense. We can first interchange any two equations, meaning if we want to move one up top or one on the bottom, we can switch them what order they are. We also can multiply any of the equations by any number other than 0, all right? And then we also can add any kind of equation, like say we multiply the first by a -2, we can add that to another equation. So we can add any multiple to each other, and that's actually what we're going to have to do. So in 6.1 you would have learned two methods. You would have learned substitution and elimination. Substitution would mean you'd solve for x and it'd have y in there, and then you go plug that equation up. But we can't do substitution when there's 3 variables, because if you solve for x, you still have y and z floating around, so it gets a little complicated. So we do the elimination method, and the elimination method means what we want to do is we're going to focus on eliminating one of the variables from the very beginning, and then we're going to go from there. So it gets kind of crazy. I have arrows going everywhere. I try to number each of my steps appropriately, so let's see what goes on, okay? So this first one, what we're going to do is notice that none of them really stand out. You can do it multiple ways. The only change in signs I see is that down here y is negative and up here y is positive, okay? So that might be a good place to start. It really doesn't matter, okay? So what I did, I'll just kind of follow my notes, but it doesn't really matter. I'm going to take my first two equations. This will be step 1, okay? I'm going to take my first two equations. But when I take these first two equations, I'm not going to rewrite them as is. I want to be able to add them together so that one variable eliminates, all right? So what I noticed, and there's a couple different ways to do it, but how I did it in my notes was, if I multiplied this first equation by a -2, what would my x become? A -2x. And what would happen when we add it to a positive 2x? They cancel. So that's my goal. I'm going to cancel my x's first, okay? So how I show this, I know it's kind of weird, but see how my first arrow goes with my first equation? I'm going to put a -2 there. That means I'm going to take this first equation, but I'm actually going to take the first equation times -2, all right? So what's he going to become? He's going to become -2x minus 12y minus 6z equals -8. So all I did was take my first equation and multiply everything by -2. I think that's perfect, because now that -2x is going to cancel with that positive 2x, so I'm going to leave my second equation completely alone. 2x plus, you can write it as 1y if you want, plus 2z equals 3. And now we're going to just add them together. So what we're doing is we're eliminating the variable x, all right? So what's going to happen with the -2x and the positive 2x? That's what we wanted to happen, right? And so this will become a -11y minus 4z equals -5. Does that look okay? And you're like, well, why does that help me? Well, now we have one equation just down to 2 variables instead of x, y, z. So what I'm going to do is I'm going to go back to my original and say, hey, can I pick any other 2? Not just the first 2, because I already did the first 2. But can I pick any other 2 and eliminate x again? And I can. It doesn't matter. What one would you want to do? Well, we're not going to eliminate z. We want to make it look like this. We want to eliminate x again. Okay?
Oh, so -3.
Okay. So do you want to pick the first one and the third one now and multiply by the -3? Is that what you're saying?
Yeah, this is
That's perfect. No, it's going to be confusing. That's fine. The whole idea is if we can get it down to 2 equations and 2 unknowns, then we're going to do the same thing, and we're eventually going to be able to isolate just y or z. So right now what we need to do is either need to pick equation 1 and pair it with equation 3, or we need to
I
pick
see what
equation
we're
2 and equation 3. Either way, we need to isolate x.
Can we do the second one and the third one? Or-
We could.
Okay.
It's a little bit harder to isolate it though, because we want to get rid of x, and so you'd have to multiply him by -3 and him by +2 or something. But notice how anytime you have a singular, he's kind of easy to focus on, because how can we have the first equation cancel out with the bottom equation?
Just put negative.
And -3, okay? So what I'm going to do,
Yeah. I was just wanting to.
I
see
think
the
you
harder
said
way,
that. Yeah, and you can do it the harder way.
Just so I could see.
You want to do it the harder way?
No.
Okay, okay.
I didn't know.
Yep, it doesn't matter which way you choose, okay? So this will be step number 2. But again, I'm going to leave my second one alone, and what am I going to do to the top one? I'm going to multiply by a -3, because I want my x's to cancel out again. So this will be -3x minus 18y minus 9z equals -12. Is that okay? Just multiplied all those coefficients by -3. And then he's going to stay 3x minus 2y plus z equals 0. So what happens to our x's? They cancel. That's what we wanted to happen. So this will become -20y minus 8z equals -12. Is that okay? So we've taken 3 equations and bumped 2 of them down to just 2 variables. So what do you think I'm going to do next?
The both of them.
Both of those, right? So what we're going to do is we're going to narrow these down and try to get either a z or y to cancel out, okay? I look at 11, I'm like, that's gross. I don't like multiples of 11. You see this right here? Yucky. But do you notice that the 4 and the 8 can be combined? So how do I change him to 8? I need to double him, but I also have to change a sign, right? So what do I need to multiply this whole thing by to make this a positive 8z so it'll cancel out with that? A negative -2, because I want to double him, right?
Oh.
So again, step number 3, I know it's kind of crazy, but they're going to go here. But we're going to multiply by a -2, just that guy. So that -11 will become a positive 22y. He'll become a positive 8z, and he'll become a positive 10. Does that look right? Not changing him at all, he'll become a -20y, a minus 8z, and a -12. And what you're going to see is we're going to actually finally solve for one of the variables. Woohoo! Okay. So what happens here? What'd you say?
Just for one of them?
Just for one, but then we'll just go backwards. It's the hardest part. So once we get one, we'll go backwards and fill it in and get the other, and then we'll go backwards and fill it in and get the third. So here, the 22 minus 20 will give us a 2y. The z's will cancel, and you're left with -2. So y is what? -1. And I'll put an asterisk, okay? We just solved for y. So how are we going to solve for the other guys? We're just going to work backwards, right? We have 2 equations. We can either pick this equation or this equation, that when we plug in y, we'll be able to find z. And then we have 3 equations. Once we have y and z, we can plug into any of those and find x, okay? So step number 4,
Can we do
we want to find z. Yep, which one do you want to pick?
the second one?
This guy?
Yeah.
Okay, so we'll take -20y minus 8z equals -12. And we're going to try to solve for z, but what can we put in for y?
-1.
-1. So we'll have -20 times -1 minus 8z equals -12. Negative times a negative will give us a positive 20 minus 8z equals -12. Subtract the 20 over, and we'll get -32, I believe. So -8z equals -32, so z will be 4. I put my little asterisks. Yay! So we found 2 of the 3. Now what can we do? We can go to any of those 3 original ones. The first one for sure, I think, because x was basically isolated, right? We're going to pick any of the original ones. She said let's pick the first one. And we're going to plug in a y value of -1, a z value of 4, and we should be able to find x. So I'll do step 5 right here. We're going to find x now by taking the first one, x plus 6y plus 3z equals 4. We don't know x, but we know y is a -1, and we know z is a positive 4. Okay? So x minus 6 plus 12 equals 4. Is that okay? -6 and positive 12 are on the same side, so just do the math. That will be a plus 6. Subtract it over, and x is -2. So how do they want you to give the answer? It's not an ordered pair. It's actually called an ordered triplet, okay? They want it x, comma, y, comma, z. So your final answer would be x, which was -2, comma, y, which is -1, comma, z, which was 4. What the heck does this mean? Remember how I used this last week, and I don't know if you guys agreed with me, but what's nice about equations is you can check them. Guys, plug -2, -1, and 4 into any of these left sides, and you should equal the right side. So you can double check all of them to make sure you got it right, because sometimes we do the math and you're like, oh, I hope it's right. So this one obviously will work because that's where we got x, but you can just double check the other ones. And they work, okay? I did it before coming here, last week when I was writing my notes. Yeah, so you can pick any of those 3, and actually you want to check all 3 because that's the whole idea. At the end of today's notes, I'll show you pictorially what we just found. It's at the back page, so I threw it at the end, okay?
Is that like a real life example?
This is actually how, so we are in 3D now, so
I didn't see that.
6.1, I know we skipped it, but it's how do you find 2 lines intersecting? It'd be just literally 2 lines and they intersect at a point. So when you have x, y, and z, it's actually 3-dimensional, and you have planes intersecting. So what we just found was this, where plane 1 is the slanted one, that would have been equation 1. Plane 2 is like this perpendicular one, that would have been equation 2, and then plane 3 is this one that slices right through the middle. And if you took 3 pieces of paper and try to make them intersect, they do intersect at one point. Okay, so that's what we just solved. Whenever you can find an actual solution, that's what it looks like. The next thing that we're going to run into is infinite solutions. So the next thing we're going to do looks like this. The plane, they could all be the same equation, so technically it's just one piece of paper. Well, where does one piece of paper intersect with that same piece of paper? Everywhere, so it's infinite. And another place it could happen is they could actually intersect at a line, but that's infinite as well because there's a line goes on forever. And then the third thing we're going to see today, guys, is sometimes they don't all 3 intersect at one place. So here, just 2 intersected, just 2 intersected, just 2 intersected, not all 3. So that's called no solution. Or they're just 3 planes perpendicular to parallel to each other. Okay? So what we found was this: if all 3 actually intersected at a point. All right, let's look at, I have a real life example right here on page 3 to say, like, when in real life do we actually have to do this?
That's how I was wondering.
Yeah, what does this, like, when do we have 3 variables and 3 unknowns? And okay, so the next thing we're going to do the same idea. Right off the bat, I noticed the first 2, I can add them as is without changing anything, and who's going to disappear?
Z.
The z, okay? So again, I'm going to kind of just do arrow, arrow. This is step 1. Leave them alone. X plus 2y minus z equals 4. 4x minus 3y plus z equals 8. And we didn't have to change them. The z's are going to cancel, right? So x plus 4x will give us 5x. 2 minus 3y will give us a negative y. The z's will cancel, and that equals 12. Is that okay?
Yeah, I just write really slow.
It's okay. Well, and I know what I'm doing too, so when we write it that way, what do you notice happens?
The Z cancels.
The z cancels out, but now that we have that new equation, do you see anything else that looks like him?
Oh, it's the bottom
It's
one.
the exact same one, right? So there's a couple of different ways to show this, but the second you do this with any 2, like we do this with any 2, and the new equation that pops out matches any of these, that means there's infinite solutions. And how can you prove it? You can be like, well, let's have our variable cancel out. Okay, so you don't have to do this, but I'll show you. We'll take him, and we'll take him, right? So this will be step number 2, and we'll take him times -1. We'll have our variable cancel out. So that'd be -5x minus y equals -12, but that would be positive 5x minus, that should be plus y up there, right? And negative times a negative. Minus y equals positive 12. What happens? X disappears,
Cancels out.
and it all equals 0. Does equals 0 equals 0? Yes, it's a true statement, okay? So this just means there's infinite solutions. So what is my math lab going to do? They're going to say, well, if there's an infinite amount of solutions, as long as you say what x is or y is, what z is, you can actually plug it in and see what it is. And so my math lab's always going to have you solve for z, okay? What is that? Or leave z alone and solve for x and y, all right? So this will be your first answer. There's an infinite amount, but then they're going to say, what is x in terms of z and what is y in terms of z? Okay, well, notice with this equation, z disappeared, right? That's kind of weird. So what we want to do is we want to solve for x by picking any of these where the y's disappear, and then we want to solve for y, okay? So step number 3, guys, I know this is weird, but we'll do another example of this like on your homework, your worksheet, is we need to solve for x in terms of z. I'll write that up there. Solve for x in terms of z. Meaning if I said, guys, on all 3 of these equations, z is 1, you could plug stuff in. So,
Should we do that with the first and the third one? Or no?
no, because our z, like we need z to be there, but we need
Oh.
y to disappear. Okay, we want to solve for x, so x needs to be part of our answer. In terms of z, that means z needs to be part of our answer. So
So it's the first 2.
first 2, exactly. I think, again, this is kind of an example of a hard one. We want our y's to cancel out here, okay? So how are we going to make our y's cancel out?
You could, for the second one, you could just put, you can multiply by 3.
I want my y's to cancel out, right?
Oh, yeah, wait, never mind.
So it gets back to like LCD. What's the smallest number that 2 and 3 both go into? 6, okay? So what do we need to multiply 2 by to get to 6?
3.
3. What do we need to multiply 3 by to get to 6? 2. Do you guys agree that they already have the opposite signs that we need?
Yeah.
Yeah, the y's are going to cancel out. So what we're going to do is we're going to multiply this top equation by 3. 3x plus 6y minus 3z equals 12. And then the second equation, oopsie, I'm barely on there, sorry. I'm like pointing to things you don't even see. And then the second equation, we're going to just multiply everything by 2, but we don't need to change our signs. So it'll be 8x minus 6y plus 2z equals 16. Did I multiply all that okay?
This is really hard.
It is very hard. But again, I don't think the next section that's really easy will make sense until you have to see what you would have to do by hand. Does that make, I know, like, you got to fight through the dirt and the hard stuff to, you know, recognize a jewel.
I just
Pretty.
feel like the steps are hard.
Yeah.
Like, I mean, like,
Well, and it's hard to also not only do them, like even if you're understanding how I'm doing them now, to like put them back on your paper to know like when you go later to do them, like what did I just do there? So that's why I'm trying to enable my step, and then like I show you my multiplication over here. Okay, so this -1's kind of way over there, so maybe I'll just put them right here. And this again, you didn't have to do. The second you saw this match that, you didn't have to really do that part. Okay, so 3 plus 8 will be 11x. The y's will cancel. -3 plus 2 is a -z equals, what's that going to be, 28? So I want to solve for x in terms of z, meaning z is going to be part of my answer. That's okay. So we want to get x by itself. So what's the first move I'm going to do to get x by itself? Who's in my way?
the Z.
Yep, so he's negative, so what am I going to do? Just add him to the back. So this will be 11x equals 28 plus z. Okay, I want to get x by himself. What do I have to do?
Divide by 11.
Yep. So x is just going to be 28 plus z all over 11. And I know that looks weird, but the whole idea is if I say in this problem z is 1, you can plug 1 in there and you say, okay, x is just 29 over 11. Or I can say z is 5, you're okay, x is 33 over 11, or x is 3. So it's an infinite amount, but we can still figure out that line that they're connecting on.
So does Y always have to cancel out then?
Nope, because then we're going to turn around and try to solve for y. Okay? You can actually, guys, turn it into, you can actually do it in any form. So you can actually solve for y and z in terms of x, or you can solve for, what's the other one? X and z in terms of y. Like you can isolate anything, but my math lab always says find x and y in terms of z. Okay, so you can do any of them, but my math lab wants it that certain way. So now we need to, step number 4, guys, is we need to solve for y in terms of z.
I'm running out.
I know. Solve for y in terms of z, which means now I need the x to cancel out. Now I would do the first and third, right?
Okay.
Does that make sense?
Yeah.
Because 1, the z's not even there, but we'll add them to 0, z or
I was
whatever.
gonna say, I thought
Yep.
I saw something happen.
So I know there's not a way to write it, but maybe over here we'll say, all right, we want to use equation number 1, but what are we going to have to multiply him by to cancel out with a positive 5x?
5. What negative?
Negative 5, right? So equation 1 times a negative 5. Just so you know where this is coming from, because I'm running out of arrows, right? So negative 5 times all of equation 1 will give me a negative 5x minus 10y plus 5z equals negative 20. All I did was take equation 1 times a negative 5. So I'm just writing that down. You guys pick which way. If you don't like the arrows, you can do this every time if you need to. And then we're just going to take equation 3. So 5x minus y equals 12.
The x's cancel.
The x's cancel, which will leave us with how many y's? Negative 11.
Yeah.
And how many z's? Just 5 z's, because technically you can write that as 0z there if you want. Equals negative 8. Is that right? And again, guys, the whole idea is to get y isolated in terms of z.
See, it's subtract.
You subtract the y of z over. So this is negative 11y equals negative 8 minus 5z. And then do what?
Divide.
Divide by a negative 11. So negative 8 minus 5z over a negative 11. And that's fine. You can leave it like that. I would accept it. But sometimes my math lab says all those negatives would cancel out, right? Right? What happens when you take a negative divided by a negative? It would be positive. And this negative divided by a negative, it would be positive. So really, you could write this as y equals 8 plus 5z over 11. They should take either or, though, like if you don't notice that. Woo! Okay, so what does our final answer look like? I shouldn't have boxed those in. Really, they want it as your x. Well, what was your x? 28 plus z over 11, comma, your y, 8 plus 5z over 11, comma, z is z. So really, I should have just asterisked those, because they still want it as that ordered triplet, right? What was x in terms of z? What was y in terms of z? And then z is z. And like I said, you're like, okay, well, why does this help me? So I can say, okay, well, what if z was 0? You could just plug it in and say x would have been 28 over 11, y would have been 8 over 11, and z would have been 0. And you just switch up z no matter what, and you'd have an x and y, depending what that z is. So what picture did he meet? He's this, because not all three of them were the same. Actually, it might have been this one. He's one of the two. I think he might have been this one because we had the 5y minus the whatever, the 5x minus the y equal to 12. Either or, you can see that it goes on forever. Actually, I think it's this because you can choose what z and then x and y would be a line. Okay, so the last one is, how do we know when there's no solutions? Basically, we do something like this, but the left does not equal the right. Okay, it's when all your variables disappear, but the left does not equal the right. So step number 1, just choose anything. Notice all three of these guys have positive values, so no matter what 2 we choose, we're going to have to multiply by a negative.
1 and 2.
1 and 2. I notice that 1 has that singular x. He's going to always be someone I choose. So let's take 1 and 2 and multiply number 1 by what?
Negative 3.
That work?
Yeah.
I think that's good. All right. So again, I kind of just do my arrows. Step number 1, I'm going to multiply the top by a negative 3. So this will be negative 3x minus 9y minus 12z equals negative 3. Just taking each of those coefficients and multiplying by a negative 3. Then we have 3x plus 4y plus 5z equals 3. And let's just see what happens, okay? Do you guys agree that the x's cancel out? So then we're left with negative 5y minus 7z equals 0. Okay, that's okay, nothing weird there. But then what we have to do is we need to pick any 2 of the originals again and make x cancel out again. I would always make number 1 one of your equations. So if we did 1 and 2, what's this one going to be? 1 and 3. Okay? Because 1's just easy because it has that x. And we need x to isolate. Remember, the whole idea is to get it down to 2 variables, y and z.
I thought you said doing 1 and 2 again. I was like,
No, so we just did 1 and 2. Sorry, I might have said that. We want to do 1 and 3. So now if I want x to cancel out with the 5x, what do I need to multiply x by?
-5.
-5. So I'm going to take the whole first equation and multiply by -5. So you get -5x minus 15y minus 20z equals -5. And then leave equation 3 alone. 5x plus 8y plus 11z equals 2. Does that look okay so far?
Yeah, I'm starting to get it now.
You'll get the hang of it. So x is going to cancel, and we're going to get it down to 2 variables, y and z. Good. So this is going to be -7y, is that correct?
Yeah.
Minus 9z
Yeah.
equals -3.
Mhm.
Did I do that right?
Yeah, I double-checked it.
Oh, you know what? I typed this wrong and I never fixed it. Shoot. Okay. Sorry. I just realized this is not working and I totally messed it up. So I'm going to have to make sure I change my notes online. Guys, this was just supposed to be a normal x. Number 3 was. Okay. So that's going to change what we do. Okay. So the first 2 are fine. We just use number 1 and 2. But will you cross this out and make that just a normal x?
Yeah.
So what we need to do is we don't need that -5 at all. We just need to change, I'm so sorry. We need to change our signs.
Pen was a bad day for this.
What? The pen, yes. Oh gosh, sorry. So I'm just going to take, again, the same equations, but I'm going to just multiply equation 1 by -1. So it'll just be -x minus 3y minus 4z equals -1. And leave equation 3, x plus 8y plus 11z equals 2. Sorry, I remember doing this, and then when I was doing it, it didn't work out, and I went back and checked because I grabbed this, these equations from the book. And I'm like, oh, I made a typo, because you know how annoying it is to type these equations? It's really annoying. So I always just copy and paste what I originally had, and then go down here and edit it. So see how that last one had a 5x there? I just totally forgot to delete him. That's my fault. And I made a correction on here to make a note, hey, Molly, go back and fix that. I just totally forgot to fix it. Sorry. All right, so the x's will cancel out. Okay, oh, good. So the x's will cancel out, and we're left with 5y. And then what's -4 plus 11? -7z, or positive 7z, right? Positive 7z equals, what's that going to be? A positive 1. And what do you notice right now with these 2 equations? If we take them together, the variables y and z are going to cancel, but then these won't equal each other. I'll show you what I'm talking about, okay? So the last thing, step number 3, is to take both of them. We don't need to change anything because they have opposite signs, right? So we have -5y minus 7z equals 0. And we have positive 5y plus 7z equals 1. What happens to the left? They cancel out, so it's 0 equals 1. Is that a true statement? Nope. So what does that mean? No solution. So see how that's different than the one we just did above. When we canceled out the variables, it made a true statement. 0 equals 0. Down here, when we cancel out the variables, if it equals 0 equals any other number, you know it's wrong. So this is an example of either one of these, and it's probably most likely this one, you have to solve it, where each one kind of meets in a line, but not all 3 of them meet together. Okay? So that's a good